Hello, everyone. Welcome back to another episode of Swift Strings with Swift. Today, we'll be coding up Leetcode 3, longest substring without repeating characters. Let's read the question. It's a medium, it's got a lot of likes. Given a string S, find the length of the longest substring without repeating characters. So, if you're given a string S like this, to find the longest substring like this that has no repeating characters, like this, like this. This is definitely not 1, so the max repeating character is 3. Let's quickly jump onto the scratchpad and see how we can do this. This question has actually a couple of solutions that I want to talk about. One of them I won't be coding up. That's the brute force solution. The one that I will be coding up is an optimal solution which includes hash map and some string traversing. Okay, so let's jump in. Hello everyone. Let's look at another brute force solution to this, and then we'll move on to the optimal approach. This is this right here is the string we want to talk about. So we want to do a couple of things in here. We want a nested for loop. Let's call the index for them as I and j, and a helper function that would help us determine if we want this particular range of I and j elements. So let's assume this is ith and this is j here at these positions 0 and 3. So we would follow through. We would initialize a set here that would carry all the elements. Okay, and once we have that set, we want to update that set one by one by looping over this range. So the helper function takes I and j and returns a boolean. Okay, and then we go through A is not there in the set, so we update it, add it in there. B is not there in the set, so we add it in there. C, it's not there in the set, we add it in here. And then we see A, which is already there in the set. So once we see a repeating element, we immediately return false. And if we never see a repeating element, we return true. Remember, we were looping through all of these indexes. So once we call this function with helper, if it returns true, update the max value, max length, which would be equal to max of j minus I plus 1 comma max. That would give us the max value. And once we're done through all of the combinations of I and j, we would return result, or no, max. And that's the solution for brute force approach. Next, we'll be looking at optimal solution. I will not be coding this out because it's so inefficient. The time complexity for this is actually n squared, because we're looking at each pair of elements in a nested for loop. So we're looking at each element twice. And the space complexity of O is O of 1, since we're not using any extra space except for this set, but that will always have a finite number of elements, so it'll be O of 1. Okay, see you in the optimal approach video. Let's look at an optimal solution for this. This is our given string right here. This is the given string right here. We want to initialize 3-4 values, right? One of them is this character dictionary right here. This would carry the element in the index it was last seen, and we would also have this last repeating position, which should be updated constantly in the loop. So we have to initialize this to -1, and then this max length, which we would be returning in the end, this would be initialized to 0. So now let's jot down s. Okay, now that we have this array, um, we want to traverse the all of the elements and update the values of update the element to the index at which it is at. Before that, we want to decide the window that we want to get the max length for. And since this is a sliding window protocol solution, we would always have a window. So initially, our window is this much. Now, there is a specific formula to calculate the max length to shrink or increase the window, the max length window. So that would be equal to so max length equals to the index it's at, so let's call that I, minus last repeating position. Since our last repeating position is nothing right now and it's defaulted to -1, it would be -1. So last repeating position, and we have to find the max of this and max length. So max, yeah, and that's essentially the formula. So let's run through the solution for this specific example. So now at first index, we would check if this A is in character dictionary. If it's not, we would just get the max length and update the value of the dictionary. So here the max length would be 0 minus -1, here this one, last repeating position, and max length, which is 0 right now. This equals to 1, so we would update max length as 1. And then after doing that, we would update the character dictionary to have the last index it was seen at. So that's here. Okay, let's expand our sliding protocol in theory, not in code yet. So we are at first position, and supposedly this should be a valid sliding window, right? This should give us a character length of 2, right? So let's how do we figure out the max length? First, we check if this is in the character dictionary. If it's not, we won't do anything. We would just update this and this. No, update this and max length. Update this and character dictionary. Sorry. So this is the index we're at. We would update max length and character dictionary. Let's update max length first. So this would be the index it's at, -1, which is still the last remaining position, comma 1. So this would be comparing between 2 and 1. And this would be equal to 2. That's the max length. So we update the max length since it's greater, and we update the character dictionary to have B1. Then we want to check if C can be included. In theory, this should be a window of protocol 3, length 3. So does it exist in the dictionary? No. So we'd update the max length and we update the character dictionary again. For C, it's 2 minus -1, comma 2. So this turns out to be 3, and the max length now is 3. So this whole thing becomes a long substring. This is a max substring up until now. Now let's change colors and just to make some distinction. Now if you want to check for A here, if you want to check for index 3, we can see that that this element already exists in here. So what do we want to do? We want to, if it exists in here, we want to update this as 0, as this here. Okay, once we have that, we can get the max length again. Let me just erase out some of the stuff. So the max length right now would be equal to index it's at 3 minus last repeating position. Okay, and what was the previous max? 3. So these two are the same thing. We don't update this again. This remains 3. But just for the sake of it, let's say we update it. And now that we have this, and we can see the last repeating position is 0, our window essentially has become this much. Okay, let's change colors again. Now we want to have this element also, b. Now we can see that b exists. Oh, we forgot to update c here. So c is 2. Okay, let's get back. We can see that b already exists in here. Let me choose a better color. B already exists here. So we want to update the last repeating position as 1. Okay, since this is 1 here. And then we want to figure out the max length, which would be equal to the index it's at. That's 4 minus last repeating position 1. Sorry, comma 3. Again, it's equal to 3. So we won't really update it, but it would still say the same. And then again, we want a different so sorry, this is now the new sliding protocol window, this window. Okay, now what if we want C also included? Now we check if C is in the dictionary. Yes, it is. So we update the value here as 2. Okay, and then we find the max again. So the index it's at 5 minus 2, then compare it with the previous max, which is 3. They're still the same. We update this, and there it is. Similarly, you can do for these two also, but in the end, your answer is always 3 for this particular solution. I hope that was informative. The time complexity for this is O of 1 because we are only visiting each element once and once only. No, O of n, sorry, and the space is O of, let's see, we are maintaining a character dictionary which could have elements that have strings, digits, symbols, and spaces. So we can assume that it's finite, right? So the character dictionary even will not be growing as the input increases. So this would be O of 1. Okay, hope that was informative. If you have any questions, let me know. Let's code this up. Okay, let's look at the code for this. So remember we wanted a dictionary. So character dictionary. It would be a array of character, a dictionary of character to its index, which is int, and we'll initialize it to be empty. And then we want a max len, which should be initialized to 0, and last repeating position, which is initialized to -1, because this is essentially what drives the shrinking and expanding of the window. Okay, and then we want to enumerate over this s string for I comma c in s dot enumerated. Okay, another thing, when we enumerate over a string, each element is not a string, it's a character data structure. So you have to take that into consideration and initialize the dictionary which we want to update. So once we have this, first thing we want to do is get the max length. Max length is equal to max of the index we're at minus last repeating position, yeah, and then max len. So we're comparing this with this and then assigning it to this again. And now once we're done with that, we can update the character dictionary to have the element and to be initialized to the index it's at currently. So what happens if there is no character in the dictionary initially? Remember, when we are at A, the dictionary is empty. So in that case, what do we want to do? we want to check if there's an element in the dictionary. So if let last character index, we're getting the last character index from the dictionary. That's this basically. Okay, and we want to check if the the last character index is actually greater than last repeating position. Okay, once we have that checked down, we can just assign last repeating position to last character index. Okay, so this essentially makes sure that we are not updating any of the values that have come before this particular index. That would save us some effort here. And once we have done all of this, what we can do is return max len. This is all of the code that I just explained in the video, the scratchpad, and let's give it a spin. Okay, the normal code runs, and this one runs too.